Good morning, dear students. Today I am going to continue the chapter 8. The next topic is concept of resistance. The topics before this topic I have explained in the live classes. So today I am going to explain concept of resistance. What is resistance? When the current flows through the conductor, then the free electrons or the particles of the medium of the wire offer some obstruction to the flow of current. The obstruction which is offered to the flow of current by the conducting wire is called the resistance. Resistance is the obstruction offered to the flow of current. By the conducting wire. It is represented by the letter capital R, and it is measured in, generally it is measured in ohm. I will explain its derived unit also, but when I will explain its formula, then it will be explained. What is the cause of this resistance? Why this resistance is caused? As we all know that the metals or the conductors, they have their free electron. The electron which can leave their orbit. So they are in random motion. The free electrons are in random motion in the metals or in the conductors. So when it is connected with the cell or the battery, or when the current passes through it, then these free electrons collide with the fixed positive ions of the conductor. They collide with the fixed positive ion, and during collision the speed or they lose their energy and their speed decreases. When they lose their energy, then their speed decreases, and because of that the current which we get on the other end has the less value, less power than which is entered from the one end. When the current enters, then the free electrons collide with the fixed positive ion. The free electrons collides with the fixed positive ion, and during collision they lose their energy and their speed decreases. Because of that, this resistance is applied, or the current which we get on the other side has less power. So we can say that some obstruction is applied by the conductor when the current flows through it. Next we have Ohm's law. Ohm's law can easily be understood by the formula V is equals to IR. By this we will get the derived unit of the resistance also. What is the Ohm's law? According to the Ohm's law, the current is directly proportional to the potential difference. According to the Ohm's law, the current is directly proportional to the potential difference, provided the physical condition like temperature, pressure remains constant. Current is directly proportional to the potential difference, provided the physical condition like temperature and pressure remains constant. When we remove this proportionality sign, then we have a constant which is R into I. This R is resistance. This R can be written as R is equals to V by I. So by this we will get the derived unit volt per ampere. Derived unit of resistance is volt per ampere. This V by I is constant for a given material. R is the proportionality constant, so we can say that it is not constant for all the material, but it is constant for the given material. R is constant. Okay. Thus the resistance of a conductor is numerically equal to the potential difference applied across its end for the flow of unit current. When the unit current flows through it, when I is equals to, or current is equals to 1 ampere, then we can see that R is equals to V. means the resistance is numerically equals to the potential difference when the unit current flows. Okay. How can we define the 1 ohm resistance? V is equals to IR or R is equals to V by I. When V is equals to 1 volt, I is equals to 1 ampere, then R is equals to 1 ohm. This is the symbol of ohm. When unit current flows through the conductor, or the resistance is said to be 1 ohm when 1 ampere current flows through when the potential difference is 1 volt. Okay. Next we have the conductance. The reciprocal of the resistance is called conductance. Conductance is reciprocal of the resistance. The reciprocal of the resistance is called conductance. So its unit is per ohm, 1 upon ohm, or it is called ohm inverse or per ohm. This is the unit of conductance. When we draw, as we know that R is the resistance and it is the ratio of potential difference and current. So when we draw the VI graph, I can be written here, V can be written here and I here. When we draw VI graph, we can change the place also. I have changed it because you will be confused that in the book it is given VI here and V here. That's why. Okay. When we draw VI graph, then we see that at the different point when they are joined, when 10 volt potential difference is applied, then we'll get some current. We'll draw the graph. 20 will get the current, 30 current. When we join these points, then we will see a straight line. If the straight line is not made, then we can say that this conductor does not follow the Ohm's law. It obeys Ohm's law only when the pressure temperature is constant, like physical conditions are constant, and we get a straight line, or we get a straight line in VI graph. Next is experimental verification of Ohm's law. As I have explained that the VI graph should be a straight line. So you take a circuit where we have a key, here we have resistance, and here we have ampere meter. This gives the amount of current. Here we have jockey, battery, and here we have the rheostat. With the help of this jockey, we change the resistance. When we press the key, with the help of this rheostat, we can apply the variable resistance. When the different resistance is applied, then we get the different amount of current. And when we draw the VI graph, when we apply 10 ohm resistance, then see the value of potential voltmeter. Here voltmeter is also connected so that we can see the potential difference. When we apply 10 ohm resistance, then we get the reading in voltmeter and ammeter. Note down the reading, change it. We can apply variable 20 ohm, 30 ohm, 40 ohm, and draw the graph between V and I. For different values, draw the graph between V and I. You will see that when the graph is drawn between V and I, you will see that a straight line will be obtained. So we can say that it obeys the Ohm's law. Next we have ohmic and non-ohmic resistor. Ohmic resistor, the conductor which obeys Ohm's law, means which gives a straight line when the graph is drawn between V and I, is called ohmic resistor, which gives a straight line. And non-ohmic, the conductor which do not obey the Ohm's law. It means that when the graph is drawn between V and I, then in case of non-ohmic resistor, we'll get a curve or any other shape. So we can say it is the non-ohmic resistor. I hope it is clear. The remaining topics will be explained on next lecture. Thank you.